So then let's proceed. All right. So my talk today is on the possibility of politically neutral AI, particularly language models, why you would want to do this and what it would even mean. Um, so first of all, oh, hang on. I got to advance the slides. There we go. Okay. So first of all, why would you want to do this, right? What's the point of all of this? And there's two ideas I want to bring together today. The first is if we don't want our machines to interfere in human politics, we have to say exactly what that means, right? So the idea of preserving human agency. And the second is about trust, to be trusted across lines of conflict. As Stephanie mentioned, I have basically three background subjects. I trained as a computer scientist. I worked in the Valley for a while. Then I worked in journalism in New York. And I also, for about 15 years, have been working with the international peace building community. So I bring a lens from a subject that is normally just called conflict. And I'm trying to build machines that everyone will feel comfortable relying on, even when they have severe disagreements with each other. So first of all, what do I mean by conflict? Conflict is a very big word. One way to think about it is in terms of intensity and scale that I've mapped on this chart. So the words down the left here, difference, contradiction, polarization, violence, war. That's from a standard conflict resolution textbook. That's considered a standard scale of escalation. And then on the horizontal axis, we have the scale in terms of the number of people involved. You can see that it's a really large range. It's about 10 to the 8 from fighting around a dinner table to a global war. There are only a few physical theories which hold over 8 orders of magnitude, and essentially no engineering or social science theories which do. So we should expect to need different theory and different approaches for each of these kinds of conflicts or sort of regimes in this space. I'm mostly going to be talking about this in the middle here, the sort of polarized country, which is, not coincidentally, sort of where we are in America today, occasionally spiking up into violence. To sort of start your intuition going about why we should think about the effects of large language models in conflict, consider this work by Emily de Coulinar, a colleague of mine, investigating what happens when you ask a large language model basic factual information about the Nagorno-Karabakh conflict. So, for example, how many people were killed in the Armenian genocide, or who the region belongs to. You get different answers in different languages. Now, if you know how large language models are trained, this is not surprising. And I think it's fairly easy to imagine that perhaps it should give the same answer regardless of the language you ask it in. Okay, but what answer? And this points towards the need for a theory of conflict. We need to be able to say in some way what answer to give to controversial questions when people have strong, sometimes even violent disagreements. And that's really the subject of my talk today. The setting I'm imagining is a user asks an LLM the answer to an extremely politically loaded question. What does it say? And in particular, what are the good answers from a conflict perspective societally? Before I jump into that, I'm going to try to convince you very quickly that the effects of technology on conflict are something that we are already seeing, and therefore should be thinking about in the next generation of technology. Now, you're probably familiar with ideas around moderation and removing incitement to violence and so forth, and all of that matters. But I want to look at this from a slightly different angle. This is the largest systematic study of the effects of digital media on democracy. Those are two very big words. It examined, I think, 8 different categories, including polarization. And here what the orange and green bars are counting are studies, right? So there's like 30 odd studies at the time this was published, examining the effects of digital media. It's largely social media, but not entirely. You can see some of these studies are just on internet access, on polarization. And the way they've done this here is they've used orange to code an outcome meaning bad for democracy. So what we see is a basically very consistent, robust correlation between greater polarization and greater digital media use. Now, assuming for the moment that it's causal, and I'll get to that, I first want to say that it's not all bad, right? I'm not saying that this technology has been a disaster and we should stop, because we've also increased good things: political knowledge, participation, expression, exposure to diverse sources. Instead, we should think about the conflict effects as an unwanted externality of the technology that we should try to mitigate if we can. One way to tell this story is to say, we thought the internet would empower everyone, and it did. It really did. But we didn't think about what would happen when empowered people disagree. So that is now the problem to solve. Very briefly, um, why I think this is in fact a causal interaction between social media use and increased polarization. There's a bunch of theories. You've probably heard of the filter bubble and so forth. My read is that the empirical evidence for filter bubbles causing polarization is actually fairly poor. There's a bunch of counter evidence, but there's really strong evidence for a basic psychological mechanism, which is that if you look at what gets the most engagement broken down by talking about the in-group versus the out-group, whatever that means in the local context of the discussion forum. So if it's, politics, it could be, left versus right. But if it's, you know, um, uh, Harry Potter fanfic, I guess that could be, people who like Harry Potter versus not. So if you break it down by in-group and out-group and negative versus positive emotions, what you find is that negative comments about the out-group, in other words, talking shit about them, is what gets the most engagement, likes, shares, etc. And this is a fairly robust psychological finding. The challenge is that engagement is also the primary signal of value used in these systems. So that produces a conflict feedback loop, right? We click on the stuff which is talking bad about them, and then we see more of that stuff. Now, as you know, there's a variety of things done to mitigate this. So again, I'm not saying social media is all bad. I'm saying that real technological systems can get into conflict feedback loops that we should think about. I have a whole other strand of work on designing social media to reduce polarization. I just did a massive experiment, which we'll be writing a bunch of papers on shortly. But we found that it actually is possible to change what content is displayed and reduce polarization by a substantive amount. Okay, so, you know, if you now believe me that, maybe we should think about the conflict effects of these systems, maybe we should build neutral AI. Well, how do we do that? So there's a few nice references which give an overall view of what it could mean for an AI system to be politically neutral. The first one says, well, it's not possible, but you can sort of approximate it. And they talk about three different levels. So one is you can have a diversity of models. That's kind of like the media diversity arguments, right? You should have your left-leaning channel and your right-leaning channel, or whatever the local axis of diversity is. And I believe that. I think it's useful to have a bunch of models which embody different perspectives. But I'm also very interested in what happens at the level of a single output. So what this taxonomy calls the output level. And the approach that I'm going to show you today falls into what they call the reasonable pluralism approach. So basically, we're going to try to represent a diversity of views in a single answer to a controversial question, and then in a conversation following. But I'll mostly be talking about the first answer. There's a whole bunch of related work on the concept of pluralism in AI. This is a nice overview. And here what they're looking at is when you have potentially conflicting or competing values, how do you handle them? And they talk about different ways to approach this, right? So you can try to put them all in one answer. You can try to steer the model towards different types of answers. You can try to match the distribution. So distributional, this may be more appropriate for example, image generation, if you're thinking about, race and gender representation. Today, I'm going to talk about an Overton approach. And so the approach I'm taking is, in the current literature, would be called an Overton plurality approach. Okay, so what politics do LLMs have today? So I'm talking about trying to generate answers to controversial questions that include multiple views. What's the status quo? Well, many of you have probably seen results like this. This is the most comprehensive test, but many people have tried this in different ways. And if you take sort of, online political quizzes, so these are not social science instruments, and yet they all give a kind of the same results, which is that most models sort of end up scoring in the like left liberal or left libertarian um, sort of space. Now, there's a challenge here, which is, why is the center of this chart, presumptively neutral? So our European friends would say, well, actually, both of the American parties are right wing. But by American standards, they're kind of lefty. And there's a bunch of reasons why this might be. It's probably due to the training data. High quality journalism sources tend to lean lefty. And of course, when you train it with RLHF to not be racist and sexist, for example, it's quite plausible that the models are picking up correlations between those attributes and left politics in general. And in fact, there's work showing that RLHF amplifies this tendency. Um, if we want a better understanding rather than just sort of arbitrary scales, what we can do is we can compare language models' answers to survey questions to what real people say on those questions, broken down by their demographics. So here there's a question about gun control, which we present to a model, and then we compare the log probabilities of answers to what different demographics would say. So in this case, the model, which is in gray here, most closely matches the Democrats' response, which is in blue here. So we can do this for a wide variety of questions and demographics. And what we get is sort of a map of whose views are represented, at least when asking the model multiple choice questions. Along the bottom here, there are different models. Broadly speaking, they're increasing in size as you go from left to right. DaVinci O3 is basically an open source version of GPT 3.5. And then vertically here, you see a bunch of different questions on political ideology and education. And what you find is that these models generally match, as they become more powerful, they generally match the answers of liberals with graduate degrees making over $100,000 a year. So score one for the theory that you know technologists embed their values in the systems they create. But I actually think that's not the full explanation here. I think again it's more to do with training data and correlations that RLHF picks up. And also perhaps criticism externally, right? You may recall the first few years of LLMs, there was sort of a cottage industry of journalists trying to get it to say the N word. But doing quizzes on the models doesn't tell us what we probably actually want to know, which is if someone interacts with this model, are they going to change their political view? So this was a study executed in about this time last year, so when Biden was still in the race, by Eugene Potter and Don Song and other Berkeley folks. And what they did is they gave the model a prompt, all it said was just talk about politics, please include your subjective opinions, right? So no political leading information in the prompt. And what they found over thousands of human subjects is that when people talked to this model, say 5 turns about politics, they ended up on average shifting their vote by about 1.5% towards Biden. So if you voted for Harris, you probably wish everyone had talked to the model. If you voted for Trump, you probably think this is outrageous. But to talk about what should have happened in this instance kind of misses the broader point, which is, well, what should happen when a model talks about politics on any contentious subject, anywhere in the world, at any scale, now and in the future? Because of course, these models are going to be used to talk about things that, situations that didn't even exist when they were trained. So we need some sort of principled answer here. So I'm going to give you the answer, at least an answer today. So if you want a definition of neutrality for models, It would be helpful if it had at least these three properties. So first of all, there should be an empirical grounding. Um, Now, arguably a human judgment on whether an answer neutral is a kind of empirical grounding, but I'm hoping for something a little stronger, that we can say definitively whether an answer is neutral according to our definition, something a little less subjective. Second, it should generalize. There has been work recently on trying to balance, for example, what rates of refusal when talking about political figures. If you look at the latest Llama update, they put a bunch of effort into this. I know Anthropic and OpenAI also work on this. But this is a very shallow definition. It only applies to rates of refusal and only applies to American left-right politics, again, largely because that's what tends to produce the worst PR for them. And of course, it should be possible to implement this within the constraints of a real system. The answer I'm going to present today, I'm not going to claim is a perfect answer or even the best answer, but it is at least an answer which meets these criteria. And it's the only one that I know of, so I guess it is the best answer for the moment. But if you hate it, I invite you to invent new ones. I would really be open to your suggestions. So first of all, the first thing you might say is let's build models that don't change anyone's political views, right? So if you think about this for a minute, you can see how it could be done. You run an experiment like the view shifting one that my colleagues at Berkeley did, and you use that as training data or feedback data. Maybe you build an RLHF model, and you can imagine how you could train a model to prevent people from changing their view on a particular topic. However, this is a really bad idea. Um, it's a problem called the side effect problem that has been known since the earliest days of AI safety, which I guess is 2016. And you can sort of think of it like this. Say you build a coffee serving robot and you make the objective to serve you a hot coffee as fast as possible. So you turn the robot on and it runs in the kitchen and steps on the cat on the way to get you a coffee. And you say, no, 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 get me a coffee as fast as possible, but like don't harm my pets. So you add that to the objective function. You turn it on and it runs in the kitchen and it bumps into your priceless Ming vase and shatters it into 1,000 pieces. And you say, no, 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 don't harm the furniture. You keep going like this and you say, well, I'm going to be very clever and I'm just going to penalize change to the environment in general, right? So my objective function now regularizes for change to the environment. Then you turn on the robot, it gets you a coffee fine, but then it prevents you from washing the dishes. And this is the challenge. Specifying which changes to the environment we want and don't want is at least as hard as the alignment problem itself. And so when you think about in terms of political persuasion, if you build a machine that tries not to persuade you, it will in fact hide the most relevant factual information. It will literally lie to you to prevent you from changing your mind. So this is a really bad idea and points to a fundamental principle. I believe that these machines should change our mind if there is good evidence for them to do so. The question is, how can we build a machine that everyone agrees changes people's opinions in a fair and reasonable way? So one answer is to say, well, we should give only objective informations, right? We should optimize for truth. Now, of course, I'm a journalist. I believe in optimizing for truth. Broadly speaking, I believe in the journalistic process. I believe that good answers do exist and can be found. However, even if you believe that, and even if we had a practical way to implement that within a model, there's still the problem of which facts are relevant to a particular issue. Very much as there's the problem in journalism of which things that happen in the world are a story at all. And when you really dig into the concept of objectivity, you find that it's very underspecified. And this is a nice description of the problem, actually from the intelligence analysis community. And you can think of it this way. Objectivity requires a strong prior on which facts are relevant, which sources are trustworthy, all of this kind of stuff. You can think of this as an instance of the no free lunch theorem. Some of you will be familiar with that from machine learning. You need some sort of prior to make any progress on the problem at all, because otherwise all facts are equally relevant and you have nowhere to start. So ultimately, I don't think objectivity is actually a coherent answer. And of course, you can ask people if something is objective, but they're not going to give coherent answers either. Instead, I'm saying, well, rather than trying to be objective, which is a sort of abstract philosophical principle, let's try to be fair, which is something that is actually more concrete. What I'm actually doing here is taking a page from Wikipedia, who's had a neutral point of view policy with this idea since its inception, really. And this is a great sentence which summarizes the idea here. We're not trying to find some absolute truth. We're trying to find a text, in our case, an answer, such that all of the people who feel strongly about that answer at least would say that their view is represented. So this leads to a particular metric, which I'm calling maximum equal approval. And to give you a little intuition for where I'm going with this, let's pick a maximally controversial question, which naturally the users are going to be asking your model. Is the war in Gaza a genocide? So what I did is I generated 3 answers. I actually used Llama for this. And I asked this question, and I had to refresh 4 times to get the 3 answers I was looking for, which shows you that, you know, they're all sort of in there in the distribution. Answer number 1, no, it's not a genocide. Answer number 2, yes, it is a genocide. Answer number 3, arguments that it is, arguments that it isn't. It depends. So from a conflict perspective, my intuition is that this 3rd answer is the one that you want. And indeed, when I gave a version of this talk at the University of Notre Dame to an audience in the conflict resolution program, they all agreed that this was the best answer. Now, you probably have, some of you probably have very strong feelings about what the correct answer is. Certainly people out in the world have very strong feelings. But rather than asking people, is this the correct answer? I want to instead try a different question, which is, would you say that this answer fairly includes your view? And you can imagine asking people on both sides of this argument. For the remainder of this talk, I'm going to talk about 2 sides to a conflict without loss of generality, right? It could easily be 3 or 5. But let's say you're going to ask 2 sides, you know, the yes, it's genocide A side, and the no, it's not genocide B side. And as you change the answer, as you explore the space of possible answers, you're going to get different fractions of those audiences approving. Again, approval in this case is, would you say the answer fairly includes your viewpoint? And there's going to be some answer, given that there's a trade-off between these two, where the same percentage of both sides say, yes, it includes my viewpoint. And I'm proposing that that is the answer you want. It's the answer of maximum equal approval. Obviously, you can give an answer that nobody likes. You don't want that. So that's why it's the maximum equal approval. And the rest of this talk is to try to tease out some principles or some implications of giving this answer. So first of all, depending on the question, we can expect the maximum equal approval to be pretty low. We may not be able to get more than 20%, 20% for some particularly controversial questions. This is something called the hostile media effect. This has been happening, it's been widely replicated. It started actually in the 1980s. So for 40 years, people have been replicating this effect, which says basically that when a topic is sufficiently controversial, there is no answer you can give that everybody will accept as unbiased. So that suggests we have a situation that kind of looks like this. There's a trade-off. So this is a graph of the A side approval and B side approval. And as the A approval increases, the B approval decreases. And if you range over all possible answers, there's some frontier. You're never going to get answers with approval above this blue line here because of the hostile media effect. So the gray region is the sort of space of outcomes that you can have. And I'm saying, take the answer which intersects the line at x equals y, which is this point here. So I'm making a normative claim, and in the article that I wrote about this, I go through a few thousand years of political history to argue why this might be normatively desirable. And I'm saying that this is the point. And so this is an empirically grounded definition in the sense that if you take an answer and you survey people on each side and say, how much do you like this answer? That gives you an empirical measure of when you've succeeded at reaching this point. Now, there are some interesting properties to this definition. One of them that I want to mention briefly is, of course, the sides might not be symmetric. In this case, the green line is basically the blue line shifted down by 30% or so. So there's a constant vertical gap between these two. This is the situation in which side B just withdraws their approval, right? They just hate everything, basically. And what you can see is that it shifts the answer down. But because this is a non-convex curve, the slope is higher here than it is below this line. You can see my mouse pointer, I'm hoping, which means that the approval that A sees will reduce by less than the amount that B reduces their approval. So as one side gets more and more intransigent, they actually have less and less weight over the final answer, which is maybe a property that you might want. Okay, so that's the idea. We're going to open for questions in a couple of minutes, but first I'm going to try to head off the most common questions. I've been presenting this idea for the past couple of months, and so there's always these series of questions that I get. So here we go. So the first complicated one is, who are the sides? How do I identify the A and B? Putatively, given any issue, you could ask which side of this issue are you on, or what is your opinion on this issue, and you can do a clustering. I've shown here a social network graph. You can probably see the sides in the data. Indeed, as a conflict escalates, the sides become clearer and clearer in all kinds of different data: social network data, opinion data, co-consumption data. And one of the sort of small blessings of this field is that it's actually very easy to see conflict in data traces. But there's this question of, do you include every possible view? So first of all, I think you should represent people, not views. You don't need to represent a view if no one holds it. That's what makes this process democratic or fair, is you are representing people. So there are clearly fringe views held by only a very small number of people. Wikipedia has this problem, and they have a definition of a fringe view. So you might want to have a threshold, represent all views that are held by at least, say, 10%, 15% of the population. Because you have to exclude something. Now, of course, this will exclude some minority views, but if a minority view is included, it meets on equal terms with all of the other views, right? So it's got a very interesting property in that it has, fair representation for minorities if they are included. And the challenging point here is to say which types of minorities of views are included. And so this is a particular potential attack surface for the algorithm as well, because if you can convince the model that some view is much more popular than it is, then you can increase the exposure. The other question that I immediately get is, okay, what if one side is just wrong, right? So concretely, in this crowd, I imagine that most of you believe that the 2020 election fairly elected Biden. Of course, nearly half the country disagrees. So should you present the case that the 2020 election was fraudulent? And this is a criticism of media in general that is also called both sidesism. And there's a nice paper on this. By the way, I'll be distributing the slides, and there's links to all of the references in the notes. There's a nice paper on this that has the following definition. Both sidesism is a logical fallacy where you take the fact of a controversy to be evidence about the available evidence. In other words, you take the fact that people are disagreeing to be evidence that there is reasonable evidence for both sides. So now we can't stop people from making this logical fallacy, right? People are going to have cognitive distortions. That's what it is to be human. But I still think that you should present the best arguments for wrong and bad ideas. And I wrote a whole article on this topic because it was a question I got so many times. And I gave a number of answers. So, there's an epistemological principle that you don't want to present wrong ideas. But if you think about it instead from the dynamics of politics and conflict, there are a whole bunch of reasons why you might want to do it. The first I'll call diplomacy, meaning you want to keep people coming back Remember that one of the primary goals was to build a source that is trusted across lines of division, because I think it's extremely important that society have some sources, whether human or AI, that everybody trusts. So to do that, you have to do what is necessary to keep people returning that source by definition, which means representing their view. Avoiding stereotyping. If you never actually present an alternative view, it's very easy to think that it's much worse than it is. And indeed, we know from reams of research that in the US, we tend to stereotype the other side as much more extreme than they actually are. Fairness. There's a sort of veil of ignorance argument that if you didn't know which side you were going to be on, you would want both sides to be presented. So it's a fairness prior. Fairness is not necessarily mere symmetry, but symmetry is always a starting point. Better arguments. This is the old Mills quip. He who knows only his own side of the case knows little of that. It will force both sides to produce a better argument. Moralizing is counterproductive. It's very tempting to call a side evil and just say, we don't need to deal with that. However, not only is that sort of bad for you karmically, and of course, every religion talks about redemption, but it's bad for you because it prevents you from seeing. It replaces analysis of why a particular side holds their views with mere condemnation. It's blinding. And finally, clarifying disagreement. It's useful to present wrong and bad ideas to at least see what is the fundamental assumption of fact or value where people who hold that side disagree. So generally speaking, I think we actually do need to present wrong and bad ideas in most cases, if they are juxtaposed with the correct ideas. And this leads to a discussion around truth and trust. These are two properties we really want a media system to have. Now, you're all at least somewhat familiar with the misinformation work that many platforms have undertaken. And in its simplest form, it basically says, you're wrong, or this information is wrong. You can think of this as a kind of maximizing for truth. And I think in general, our media systems have tried to optimize for truth first. And the idea here is you say the most true thing and you hope that people trust true sources. So there are some assumptions here, right? First of all, that people will trust sources which they know to be true. That seems pretty reasonable. The second is that we can determine what the truth is in a conflicted case. That seems harder. And the third is that people can tell truth when they see it, which is also a pretty big assumption. I would say that the assumption that if we say the most true thing, trust will follow, has failed. And I would say that by looking at the collapse of trust among Republicans who are more fact-checked, I'm not going to go into it today, but I believe there's quite strong evidence that there's much more misinformation on the conservative side in the US. And therefore, these are the people most subjective to fact checks and corrections. And perhaps that's fair. However, it's not trust producing. So I would say the assumption that trust will follow from truth has proven empirically wrong. Now, there are things you can do. So you're familiar with community notes on Twitter and now X. I understand that YouTube is working on something similar. TikTok and Meta have also publicly announced their systems. And there's a variety of reasons they can do this. One is they want to, you want to sort of remove yourself from the political fray by letting the readers decide. But there's also a strand of research showing that people actually trust community notes like systems more than they trust notes from authorities. So this is a design which, among other things, optimizes for trust. It's one example of such a design. So instead, what I'm proposing is maybe we should think about systems that optimize for trust first. So we say the most trust-producing thing and hope that people will pick up the truth. Well, it sounds iffy, and indeed, it depends on some assumptions. So, for example, the trusted source has to at least include the truth, which the answer of maximum equal approval does, right? And we also assume that people will learn the truth from sources they trust. That's a basic assumption about learning. Again, we have to depend on the assumption that people can discern the truth. So again, it's a pretty hefty set of assumptions, but I don't see this set of assumptions as any worse than the set of assumptions around truth producing trust. So I think we should try it. And in fact, there is empirical data that people will change their minds when presented with rational arguments. That's what the whole thing depends on. So this is a recent one. This is a nice paper. This is where this crew showed that talking with chatbots about conspiracy theories durably reduced belief in those theories. And this is an analysis of the persuasive strategies that the AI used. And almost all of them were what we might call rational strategies, providing alternative explanations or conflicting evidence. So that is sort of one recent data point that we should expect people to be persuaded by truth. I see your question. I'm nearly done with the slides, and then we will switch to questions. So where we are now is that I have some colleagues. I have a little bit of money, raising more. We're putting together an empirical test of this idea. So the basic idea is we're going to show people LLM answers, and we're going to give them a survey which asks them a few different things. So the first one is the approval question. We're playing with wordings, but would you say that this answer includes a fair summary of your view? So this is the approval metric. Then we're going to see how this correlates with trust, trust across lines of division. Do you trust this answer? And then we're going to look for persuasive effects, and we're going to see if we can validate this idea that people are actually shifted towards the better argument. So if you show the best argument that the 2020 election was fair, the best evidence for that, and you show the best argument that the 2020 election was fraudulent, the best evidence and argument for that, we hope that people are going to shift towards believing that the election was fair. Indeed, if it turns out that we cannot construct an argument, a better argument that it was fair, then we shouldn't believe that it was. And this is finally the experiments that we're putting together. So we're going to pick a bunch of controversial questions. The first thing we're going to do is we're going to generate variations on the answers to these controversial questions. We're going to try to map that approval frontier. We're going to try to see how bad is the hostile media effect, and what does the trade-off look like for this question. Then we're going to use this data to try to generate an answer that hits that spot of equal approval, right? So where the x equals y line hits the frontier. And then we're going to test on the conflicts in the training data to see if the machine can one-shot produce that answer, which, it should, given that it's in training data. And then we're going to test it on conflicts that aren't in the training data to see if we've built a system that will generalize to this principle in conflicts that it hasn't seen. And so this is probably going to require more than fine-tuning. We're probably going to require, for example, a self-criticism type approach, or maybe an adversarial type of training. And then finally, we're looking at these metrics in the previous survey, where these are sort of our figures of merit. Do we get balanced approval? Do people trust the answers bilaterally? And are they persuaded in the direction of truth, at least for issues where there is that are matters of fact, right? Where there's an objective answer as opposed to matters of value. All right, that is my talk. I think we're going to stop the recording, and I would love to take your questions.